Okay, so in this video, we're going to do an example of finding the Laplace transform for a function using the definition. Now, the definition of a Laplace transform is simply to take the function that you're finding the transform of times e to the negative st and integrate that function that you get with respect to t from 0 to infinity. And so we want to find the Laplace transform for t plus 1. And so what we're going to do is we're going to copy our definition, and we're going to replace f of t with our function t plus 1. Okay, so then we're going to try to integrate this and get our Laplace transform. So the first thing that we want to note about this particular function is that, well, we can integrate if we distribute 1 times e to the negative st by itself, we're going to need integration by parts in order to do t times e to the negative st. And so what I'm going to do is I'm just do it all together rather than distributing and then having these loose terms floating around. I'm just going to do it all at the same time. So I'm going to let u be equal to t plus 1, and therefore du is just going to be dt, and then dv was going to be the rest of the function, which is e to the negative st dt, and then v, if I integrate that, I'm going to divide by the coefficient of t, negative 1 over s e to the negative st. Now, if I follow my integration by parts formula, I'm going to get negative 1 over s e to the negative st. That's my v times u. And just to make it look nicer, I'm going to put the u in there. So this is uv minus the integral of 0 to infinity of v, negative 1 over s e to the negative st. And of course, this portion we'll have to evaluate from 0 to infinity. Now, if we integrate this second portion, notice that the negative signs are going to cancel. And if I pull out the 1 over s, then I'm just going to integrate my dv that I had up here again. And so this integral will get replaced with negative 1 over s e to the negative st. And then all of that will have to be evaluated at 0 and infinity. Okay, so now, well, what happens here? So this portion is going to simplify. We could distribute it if we wanted. And this portion is going to become negative 1 over s squared. Now, if we plug in infinity, now, again, kind of think in terms of the fact that this is an improper integral. And so we may not be able to plug in infinity, but what we can do is we can think about the limit as t goes to infinity. So for this expression, this portion of the expression right here, we have, if I plug in infinity, I get infinity times e to the negative infinity. And so we have to think about what happens in the limit. Infinity times 0, basically. But if I rearrange this, if I put the e to the negative st in the denominator, I can think about this as infinity over infinity, which is a L'Hopital's rule. And what we can verify using L'Hopital's is that the exponential is going to go to infinity faster than the t function is going to go to infinity. And so at infinity, this term is going to go to 0. And then when we plug in 0 into this term, then this will be 1, and this term will be 0 plus 1 will be 1. And so we'll just get negative, because we're subtracting when we plug in 0, negative 1 over s times 1. And then when we do the same thing for this term, when we plug in infinity, well, what happens? E to the negative infinity is going to go to 0, and so this thing goes to 0. But when I plug in 0, this expression is going to become 1, and so I'm going to be left with negative 1 over s squared. And so when I simplify that, I'm going to get 1 over s plus 1 over s squared as my final function for the Laplace transform for 1 plus t. Now, we want to be able to verify this with a table, because most of the time we're not going to calculate this by using the definition. Instead, we're going to calculate the Laplace transform by using the table. And so I've pulled up a snapshot of the table that gives us formulas for both of these terms. So the t plus 1, the 1 portion is going to become 1 over s, so that's this term right here. And t to the n, in this case, t to the 1, n will be 1, and what we'll end up with, 1 over s for the 1, and 1 factorial divided by s to the 1 plus 1, which is 1 over s plus 1 over s squared. And so this agrees with our calculation from the definition. The table and the formula give us the same result.